We are live today. Hello, Carly and Heisenberg. Don't know if you're still around. Let's get going. We're gonna do some mixing experiments today for sure. But we're gonna start with the old acid base color changing reactions. Then we'll do some of those separation science reactions. We'll get it going. It's a little, hey, what's going on, Carly? What's going on, Arjun? A few drops of hydrochloric acid here. Excuse me, sodium hydroxide. What am I talking about? Indeed, Rage. We got the fast, large spinner on the left. We've got the slow, small spinner on the right. We do got a mini whirlpool going. Oh, Charlie, staying up too late. What time you gotta get up, Charlie? Mini sodium hydroxide rainbow whirlpool, baby. All right, here we go. We got to get some colors going on here. What do we got? Like, usually 5:30. You better get to bed. I need my 8 hours of sleep. You're already only going to get 7.5 tops. Let's add some sodium hydroxide over here on the right. Get that speed going up. Let's get our pH scale. Right here. There's our pH scale. Look at that over there. We got pH 3, pH 10 in the same medium. That's a difference of proton concentration of 10 million times, man. Let's do some acid over here on the left. Get that nice and red. All right, let's even get the rainbow. Come on now. Let's get some rainbow action going on. Let's do 2 drops sodium hydroxide, see if we can pull it off. Here we go. 1, 2. Let's go, baby. Let's go, baby. There it is. Got a little rainbow flash for folks. Let's make this acidic over here. I'm going to add some hydrochloric acid over here on the right. We're going to add some hydrochloric acid over here on the left. You'll see the pH drop. The way you can see that, oh, it's some pretty color change. The way you can see that, the pH is just going to match the color that you see in each flask with the pH chart that you see here. That tells you whether it's acidic, basic, or neutral. Yes, indeed. Yes, indeed. What kind of colors you want to see? Drop your emoji heart in the chat. Thank you there, Ola. Appreciate that. All right, let's do 2 drops of sodium hydroxide over here. That's going to raise the pH. Take some time for everything to mix, so we should see a bunch of colors. Here we go, baby. Come on, give us the rainbow. I saw a little flash of it. Hey, thanks there, Griff. Appreciate that. It's not that much math, Orlando. Not too much math at all. We don't get into it if you don't want to, but some people want to, and we talk about it a little bit. I'm going to add some hydrochloric acid over here on the left. Notice that drops the pH. Let's add some sodium hydroxide over here on the right. You'll notice that that's going to shift it to a more blue color. Take that out of the way so we can see. Y'all let me know when you want to see the pH scale, all right? Let's stick it down there like this. I don't know. I got to figure out a way to do that where folks can see it. Let's pop this on here. This might work. All right, baby. Let's see if we can get that rainbow action going on. Hello there, William. What's going on, William? Let's do... Oh, Robert James. So you do titrations all day, huh? Sorry about that. Here we go. Let's go 2 drops of sodium hydroxide solution on the left. And you get a little flash of the rainbow, folks. Little rainbow flash for you. Oh, it's all right, Charlie. So Savage thinks that there's Mr. White here. I don't know, Savage. What do you think? You think you know, and then, got a little blue solution going on there. Maybe? Maybe? Thank you there, William. Let's add some hydrochloric acid over here on the left. Ah, Maverick. I just like to dress up for you guys. Just make it a little bit fun. All right, I've added some acid over here on the left. I think I'm going to add 2 drops of base. Let's see if we get the flash of the rainbow. Let's see, baby. Come on now. Come on, baby. The LGBT antidote, huh? No, maybe I'm just making the LGBT solution, huh? Let's get this going a little faster over here on the right. pH full form is power hydrogen. So pH, technically, let me give you the equation for it. The pH of a solution is the negative log base 10 of the H plus ion concentration. This is the technical definition of pH. pH is the negative log of the H plus ion concentration. This is really an approximation. And really, the pertinent chemical species is not the proton concentration. The proton actually binds to a water molecule and makes an H3O plus ion that we chemists call hydronium. So this bottom really gives you the real definition for pH. All right, here we go. Let's add some acid to both of these. Drop that pH, right? We're at nice purple colors. We're going to add some acid to drop that pH down, okay? Here we go. pH goes by powers of 10. So every time you drop 1 in pH value, the proton concentration or the hydronium ion concentration actually goes up 10 times. Seema says, tell me the definition of an acid-base titration. This is where you add precisely measured volumes of, we'll say base, of standardized known concentration to a known mass of acid to determine the percent acid in your analyte, the thing that you're looking at. Ah, Charlie, here we go. Let's add some sodium hydroxide here. Boom. You guys want to see the color separation experiment? I think we got the rainbow for you, folks. Here we go. Add some drops of base over here on the right. You guys want to do the color separation experiment? What do you think? Thank you there, Nunya. I think we should do the color separation experiment. Hey, administrator, doing well. Administrator says they want to see the color separation, so let's go for it. Let me show you how we do this color separation experiment. We'll take this off over here. We'll get to it. Here we go. I have a bottle here with some water in it. This is going to blow your mind if you haven't seen it before. You're going to love this. So, to this bottle of water, there's just water here. To this bottle of water, I am going to add some acetone. So I'm going to just put a little funnel here up at the top. And we're going to put some acetone in here. See if I can find my acetone. Here it is. All right. Add in the acetone. Uh-oh. I got to get the bottle open. I don't have a... Let's see if I can find my scissors here. I apologize for the delay. I need to get... Yep. Here, let me add a little base over here while you're waiting so we can see something pretty going on. I apologize right now. I'm not going to be able to see much of the comments because I am trying to get a bottle of acetone open, and it looks like I need a screwdriver to do it, but there we go. I used the end of a hammer instead. Okay, here we go. We got water in here. I'm now going to add some acetone, and it goes. Adding the acetone. Looks kind of cool, doesn't it? You can kind of see that the two don't easily mix, right? There's kind of like 2 layers. The acetone is kind of staying on the top because it is indeed less dense than the water. All right? Okay, now, I've got my acetone there. Let's take this out. Let's mix it up. We're going to go ahead and mix this up. We got to get the lid so I can do that. Where the heck is the lid to my bottles? Here we go. We'll just use this one. Oh, here it is. I put it right over here. Let me see. I'm going to read a couple comments here. All right, here we go. I'm going to mix the water and the acetone. All right, those two, they are what we say is miscible. That means they mix in all proportions. All right, so we've got our bottle of acetone mixed with water. All right, now to this mixture, you can see a bunch of bubbles there, right? Let's just focus in on this. You can see a bunch of bubbles there, but that just to show you that the acetone and the water have completely mixed, what I'm going to do is I'm going to add some of this purple food dye. All right. So you just see that the two fluids have mixed. Here we go. Let's drop them in. And that looks beautiful in its own right, doesn't it? I mean, just look at the way the dye just kind of meanders through the water. Well, it's not water. It's water and acetone, right? Is that another drop? Just gorgeous to watch, you know, just nature do its thing, man. It just does random crap, but it looks beautiful. It's really interesting how randomness can look so beautiful. Anyway, our next step, folks, is to add some salt. All right, this is just regular old table salt. So again, to recap where we're at, this bottle contains a mixture of water and alcohol. And then I added some purple food dye, neon food dye, all right? Kroger neon food dye. Here we go. Let's add some salt to the mixture. See what happens. All right. I got to get it in there. Here we go. In goes the salt. You see me adding up there at the top. Come on, baby. In goes the salt. In goes the salt. In goes the salt. In goes the salt. So I am adding salt to a mixture of water, acetone, and neon food dye. All right. Boy, look at all those bubbles. Pretty, huh? All right, let's give this a good old shake, shall we? We're going to give this a shake, and we're going to see what happens. It's going to take a while to get the acetone to mix. Excuse me, the salt to dissolve in it. We'll just keep doing this back and forth. And while I'm mixing, let's go ahead and I'll start adding some hydrochloric acid over here on the left so we can see some color changes. There we go, a couple drops of hydrochloric acid. For those of you that know what's going on in the Chem Lab here. Oh, we got a little shine of the rainbow. I'm loving it. The chaos in the bottle. I love it, Mr. J. Is this actually a Tommy Technetium live stream? This is a live stream, Mr. J. This is a live stream, okay? I am live. You got it. We got the rainbow, administrator. Come on, man. Get the salt in there. Get the salt going. I hope it dissolves. Let's see if it's working. It's not quite dissolving enough of the salt yet, I can tell. So we're going to keep going. I got to shake this up. Shake, 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 shake. Come on, man. Because it's cool when it goes. Hey, Future Farm, good to see you. I guess you've been busy, huh? Doing some studying, I guess. Well, you tell me, V. Let's see. See, I think I can change the color here. There we go. I think this is going to work. Come on. Shake this up. Shake it up. Get some of that salt dissolved. And let's see if it's going to work. Here we go. Oh, I hope I don't have a dud. No, I don't. I think we got it. I think we're okay. You can see it happening. You see it? We got a color separation. Totally have a color separation. So what happens when I add the salt is the water molecules are so attracted to the salt that the water and the salt bind exclusively. You know, kind of like two people who fall in love kind of deeply, and they decide to just see each other exclusively. A lot of people think that, administrator. Yeah, let's add a little more. Well, we can wait. So the water and the salt, they attract so strongly that, so to speak, they date exclusively, or they just, they combine exclusively. And that pushes the the acetone out. So the acetone it's not strong enough. The attractions there is not strong enough to overcome the attraction between the salt and the water. And that's why you get the separation of the two layers. Thank you there, Mr. J. I appreciate that. Now, the reason why you see the two different colors is because there's two different, colors in this dye. You can see them right here. One of them's kind of this pinkish color. The other one's kind of this violet blue. And together they give you this neon violet, neon purple. And indeed, it's very easy to see that the pinkish colored dye dissolves better in the acetone layer. And the blue dye ends up dissolving better in the saltwater layer. Tyler says it's a good analogy to their dating life. Well, Tyler, I hope you are in the saltwater layer. Let's just put it that way, huh? I hope so. Now, this is kind of fun. We do this too. I'm going to add a little bit of this to this bottle, and we're going to see what happens. Unless you want to do a different, we can do like a different bottle. We can do different colors, and we go back to doing this. I don't care. Oh, the eternal tornado. Let's do something with the tornado here. Let's add a little bit of acid here. Drop the pH. I don't have any iodine, Future Farm, but what a great suggestion. Mix the left to the right, says Dennis. I think this is what you mean. I don't know why you want me to do that, but that's probably just me. That's probably me just not understanding what you really wanted me to do. I don't really know, Dennis, but that's what it seemed like you wanted me to do. Let's add a couple drops of sodium hydroxide, get that pH changing. A little flash of the rainbow, not quite. Let's add a little acid here, get the pH to drop. I don't have any phosphorus, ice cold. How's it spinning, Maverick? It's on a magnetic stir plate, which is kind of like a magnetic fan inside a box. And then there's a little magnetic stir bar down here that when the fan spins, it turns that little stir bar. Mix the purple with the rain. Fiona, what a great idea. We can do that. Fiona says, hey, why don't we try getting the rainbow in the bottle? Let's do that. Let's try that, okay? So we're going to do the same experiment here. We're going to try the same experiment. But this time, we're going to use a different solution this time. A different liquid. Instead, this is water now. This is still water. And instead of adding acetone, this time I'm going to add some isopropyl alcohol, okay? Here we go. So let's add some isopropyl alcohol to this bottle. Here we go, folks. In it goes. In goes the isopropyl alcohol. I don't have any beryllium, ice cold. Can you tell, sort of, that there's two layers? You can see that water layer on the bottom. And the alcohol that's being poured in is kind of resting on top. You can kind of see that. Definitely easy to see two layers in this case. It's really kind of cool to see. That's probably good enough. Okay. Now, let's add the acid-base. We're going to add the acid-base indicator to this one. What's the acid-base indicator? It's the stuff that I have in this solution over here. So if you see, I'm going to go ahead and add some sodium hydroxide over here. And when I do that, the dye shifts to a more blue color. And that's, that's just your pH scale. When you add base, you're going to go this way on the chart. When you add acid, you're going to go this way on the chart. All right? So let's add some acids. You can see what I'm going to add here. Let's add a bunch of acid here. And, of course, when I add those drops of acid, we go to a more red, yellow, or orange color. Thank you there, David. Okay, now we're going to add this indicator. It's called Universal Acid-Base Indicator. We're going to add it to this bottle over here. Where's my dropper? Here we go, baby. Come on now. All right, let's pull this up. You see how it's green in color? All right, so we know that it's neutral. When the acid-base indicator is neutral, it's going to have a green color. I'm just going to add it in here. Let's see what happens. Squirt that baby in there, and look at that. It looks like it's stuck in the middle. Why in the world would that be stuck in the middle? Well, that is... I don't have any sulfuric acid. Sorry about that. Sorry about that. That's because, remember, at the top layer, there is alcohol. And at the bottom layer, there's water, and the two have not mixed. Let's see if we can make a mix. We're going to see if we can make a mix, okay? Absolutely, Hunter and James, is because of density effects. The alcohol that I added is going to be less dense than the water. And so there's two layers there, but we can make those two layers mix. Here we go. At least I think we can. Let's try it. Here we go, baby. Here we go. Mix that up, and if it gets yellow all the way through, we know that indeed the alcohol and the water mix. Look at those bubbles too, man. All those bubbles are kind of cool. Okay, now we're going to add salt. And if you've been on the live before, you know that when you add salt, can I mix it ice cold? There's isopropyl alcohol in here, and that gives people pretty bad diarrhea. So, it might end the live in 10, 15 minutes if I gave it a shot. But I don't think I'm going to do that for today. Is that all right with you? Okay. Now, here's what I'm going to do. I hope this works. To this mixture of water and alcohol, I'm going to add some salt. This is called salting out. Maybe you'll see why here in a bit. Let's add this. Why does vodka stay mixed instead of separating water and alcohol? Dennis, because just like here, just like this type, alcohols with a small number of carbons mix very well with water. And the alcohol that people drink has 2 carbons in it. This alcohol here has 3 carbons in it. And, small alcohols like that mix real well with water. Okay, now we got a mixture of water, alcohol, it's isopropyl alcohol, and some, and some universal indicator. I'm going to put some salt in here. And the salt and the water, they are going to mix really well. They're going to mix so well that they're going to, what I say, date exclusively. And because the attraction between the water and the salt is going to be so strong, they're going to push the alcohol out. We call this effect salting out. It's going to take some time for the salt to dissolve, but when it does, you're going to love the result. Let me get this a good shake. Shake, 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 shake. And while we're waiting, because this does take some time, I'm going to move over here so we can take a look at our pH bottle. Now, this, incredibly enough, has the same dye in it that this does. So watch what happens when I add some sodium hydroxide, which is a base, to this thing here. A couple drops. And you can see, of course, when you add a bunch of drops, of course, you see a flash of the rainbow. But when you add base to this particular dye, it gains like a blue. Here, if we add a little more, we'll get it to go violet. All right? So violet is as far as we can go on the base end. Will it only do it with salt? David, there are various types of salts. So when a chemist says salt, it can mean anything from what a chef means when a chef says salt, which is sodium chloride, to any number of ionic compounds. Okay, now what we're going to do is we're going to add some acid to this flask over here. Christian, if you want to see that, you can check out my YouTube shorts. I've already done that. You can check it out. I make some piranha solution, and I think I stuck a scrub daddy in it. So here we go. Let's add some hydrochloric acid to this here. There's 1 drop. Here's another drop. I'm adding hydrochloric acid. It's the same acid that's found in your stomach. I'm adding it to this bottle over here on the right. There we go. There's another. Still trying to get this salt dissolved. Let's see if it's done. I don't know if it is or not, but we're going to find out. Hopefully it's not a dud. Let's keep adding some hydrochloric acid over here. Oh yeah, I think that's working over there on the left. I think it is. Man, I think I got to get a little bit more dissolved. But if you look carefully, you can see up here at the top, it's got like a darker yellow color. And down here at the bottom, it's got a lighter yellow color. That's because the dye, the indicator dye, goes into the alcohol layer much better than it goes into the saltwater layer. Again, you remember, I added some salt to a mixture of alcohol and water. The salt and the water bind so tightly, it's like two people who fall in love and decide to date exclusively. They bind so strongly, they push the alcohol out. So you can really see three layers if you're careful here. You got the alcohol layer on top with a nice yellow color. You got the saltwater layer on bottom with a pale yellow color. And in the middle, there's what we call an emulsion. It's a mixture of the alcohol and the saltwater layer. And that emulsion layer will slowly shrink over time. Hey, yeah, we got close, man. We almost got 1,000 students in my chemistry class. Come on, baby, let's get there. Come on, baby, let's get to 1,000. I don't know if that's ever happened to me on YouTube, but we'll give it a shot here. Now, what we're going to do, though, just like I can change this color dye by adding base, which you'll see me doing here. I'm adding a little bit of base. And now over here on the right, I'm going to add a little bit of acid, and you'll see that the dye is changing color when I do that. We're going to try doing that over here. I'm going to just start adding acid or base to this stuff. And the reason why you see the color changing happening is because this is, it's a acid-base indicator. And that acid-base indicator changes color depending upon pH. And these are the different colors you will see at the different pH values. Like now, it's like a green color. So it's like, it's a little bit bluish green, so it's a little above pH 7. It's just a little bit basic. If I start adding acid to it, I'm going to add hydrochloric acid with the same acid that's found in your stomach. You start to see that pH drop. Come on now, we're down to about pH, I'm going to say 4, maybe 3. Let's start adding some base, get the pH to rise. There's one drop of base. We went from pH 3 to pH 4 at the top, pH 7 at the bottom. It looks like it's going to relax to like a orange color, so we're at pH 5. Let's add another drop of base, and we're seeing that. We got to 1,000, baby. Come on now, Dylan. Mister, thanks for letting me know, man. Awesome. And now we got a blue color, so we're here. So, look at this over here. We got the color separation. We got the alcohol layer on top. We got the saltwater layer on bottom. That's really cool, man. Thank you all. Thank you all for getting me 1,000, man. Here. We got to 1,000. We got a blue-colored solution. Tony D just sent me $1. Everything's good in the world, man. You guys got it. You guys earned this. You guys earned it for big time, yeah? Welcome aboard. I'll tell you this. My name's not Walter, but my grandfather's name was. That's all I'm going to say, all right? Let's switch this back around. Let's add some acid or base to this bottle right here, all right? And we're going to see what happens, okay? Yeah, we hit 1,500 there for a second. Boy, it's taking a while to separate. I wonder if it's because I just don't quite have enough salt in there, or maybe the water's not warm enough. The separation's going kind of slow here. That was cool, man. Thanks, everybody, for hanging out. Future Farm, thanks for the $1 you sent. I see you. Come on now. Appreciate that. Appreciate that. Fire truck guy, welcome aboard. Trey Mover, the pool guy. Trey Moore, of course. Jackson Notenheisenberg. Luke Notenheisenberg. I reuse them, Dennis. Ha! I love it. I love it. IMK had a grandfather named Jesse. Show the other bottle. This one. There's the other bottle. Hey, someone from the Seashells. I love it. I love it, love it, love it. Somebody just sent me a $9.99. Come on, Future Farm. Come on, baby. That's crazy. I really appreciate that. You don't need to do that, honestly, folks. Well, I'm just out here in my basement having a good time with y'all. Hunter, thank you. Hunter Young just sent me $2. You guys are something else. Really, you don't need to do this, but I appreciate it. I really do. Okay, here we go. We're now going to add some, let's add acid to this, okay? Let's add a little bit of acid. Remember, we got the universal indicator in here. Yeah, we're doing some science there, Peiko. We are doing some science. I'm trying to read the comments there, Baked, but they're coming through fast and furious. I'm doing the best I can. All right, here we go. Let's add some hydrochloric acid here. Can you see that red color going in? That makes sense, right? I mean, it's just going to do the same thing it always does, right? When I add acid, the pH should drop. And what's interesting is you can see that the base is more dense than the alcohol where it sinks down below, and then it rests on top of the salt layers. saltwater layer. So we know that the sodium hydroxide solution that I've added, the base solution I added, is more dense than the alcohol, but less dense than the saltwater. Sandmeyer reaction, Rishi. I don't know what a Sandmeyer reaction is. You're going to have to teach me something. That sounds like something in organic chemistry. It's been like 30 years since I had organic. Oh, okay. We got someone who's got a YouTube channel called The Fire Truck Guy. All right, here we go. I don't have any calcium carbonate with me, Sabir. All right, here we go. Here we go. Let's shake that up. And everything should turn like an orange or a red color. David, the bottom of the bottle is cloudy because not all of the salt dissolves. So that's what's going on there. So it looks like we got a color shift, right? I added some acid, and we went from like a pH of 6 down to a pH of 5 or 4, so it's getting more acidic. And we're still getting the color separation. But look, it looks like the, as we're lowering the pH, the dyes do not dissolve quite as well in that saltwater layer anymore. Could I add some baking soda? Unfortunately, Trey, I don't have any. What's really nice right now is you can see the 3 layers really well. We've got the alcohol layer on top, we got the saltwater layer on bottom, and in the middle you have what's called the emulsion. The emulsion is a mixture of the alcohol and the saltwater layers. Twitch, I have seen Now Red. Absolutely, he's great. Love it, love it, love it. I have Blueberry Boy. Yep. Hello, Fire Truck. Hello there, Esteban. Hello there, Chase. Suspension versus solution. You got it, Double. Chemist has entered the chat. Can I make it neutral, says Sabir. We're going to try that right now. Here we go. Here we go. Thank you there, River. I appreciate that. This is kid friendly. I can't promise, Craig, that the comments will be, okay? Is the Leidenfrost effect the reason if you pour liquid nitrogen on your hand? That's exactly right. That's exactly right. Okay, here we go. Walter H. White. Come on now. You got some competition, Walter H. I'm just letting you know here. Back at it. Let's add some sodium hydroxide solution. We're going to try to get this to pH 7. Let's add like 2 drops. See what happens. All right. 2 drops sodium hydroxide solution. Thanks for that, Nathaniel. Appreciate it. Appreciate all the love, you guys. Give this a shake. That doesn't look like much happened. Oh, yeah, I see a shift to yellow. I see a slight shift. Oh, my goodness, it went all the way to green. That's kind of cool. It just took a little bit. So notice I added base. We were down here like pH 4 or 5. And then I added some base. Well, shoot, it went green. Now it's back to yellow. So it looks like it leveled off at like a pH of 6. Thank you there, Izzy Dizzy. Absolutely, it's incredible, Paul Howard. Let's add, oh, that's looking pretty, though. Boy, that you can really see the 3 layers really nicely. I see the alcohol layer, pardon me. I see the water layer, saltwater layer, and I see the emulsion really well. Craig, the dye that I'm using is Universal Indicator. It's actually a mixture of 4 different dyes, but you can just buy the bottle. Thank you there, Love and Life. Can I show fluorescein under UV? Like uranium in the movies from Germany. We got some folks from Germany. That's awesome. I don't have any fluorescein with me. I'm in the basement here. Does it change each time you shake it? PG. So what I'm doing, PG Dub, watch this. I'm going to open the bottle just so you know. And in this bottle is the same dye that's in this over here. They both contain the same dye. Now watch what happens when I start to add acid to this flask on the right. You notice that things start to get more red. And that's because the dye behaves like this. So more acid, it's going to go more yellow, orange, or red. Now watch what happens over there on the right when I start adding base. Boom, boom, boom. And things start to go more blue. So that's what I'm going to start adding over here on the right. So we're at like a pH of 6. I'm going to add like 2 or 3 drops. 2 or 3 drops of base. Craig, the salt that I'm using is sodium hydroxide. Let's go 1, 2, 3. Let's add a bunch. There we go. Oh, that's nice. You can see the sodium hydroxide solution is more dense than the alcohol, but less dense than the salt water. You can see it made it like a little bit of greenish color. I'm going to add just a little bit more. There we go. Come on, baby. Let's see what happens when I shake this baby up. All right, shake that up. Hey, look at that. We got a blue color. Beautiful blue. Here we go. All right, let's see what happens now. This is when things get really interesting. Come on now. This is where it gets really interesting. I love it too, Saint. Thank you there, King Roy. Come on now. What the heck is going on? What is even happening? We got a blue layer on top. We got a violet layer on bottom. What gives? What in the world is going on? The acid and base I'm using done is 20% by weight sodium hydroxide, 20% by weight hydrochloric acid. So what's happening here is you need to understand that universal indicator, this indicator over here, actually consists of multiple dyes. I know, it looks crazy, but you're going to get this, okay? It contains multiple dyes. It actually contains 4 dyes, okay? Let me show you the 4 dyes it contains. It contains thymol blue, which shows these colors at different pH values. It contains methyl red. It contains bromothymol blue, and it contains phenolphthalein. So basically, we're at like pH 10 in this bottle. How do I know? Because I see this, that's why. Anyway, at pH 10, you know, you add all these colors up together, and it usually looks violet, right? Blue and a little bit of yellow and blue and a nice red color is going to give you a violet. And that's what we have over here. We have a pH 10 solution over here. But this is well mixed. Over here, we have, the same dye in there. It's got the same 4 substances in it. But it just so happens that this one, phenolphthalein, at high pH, dissolves in the saltwater layer. It undergoes a slight chemical change that makes it dissolve in the saltwater layer better, and everything else dissolves up here in the top. At all other pH values, they all tend to go to the top layer, but when you get to a high pH, the phenolphthalein crashes out and goes into the saltwater. Isn't that cool, man? Is that not cool? Here, let's make it go reverse here. I'm going to start adding some acid to this. We're going to watch what happens. It's not hot, Xenon. Interesting. So you're seeing more salt crash out when well, I'm not seeing much salt, to be honest with you. Here we go. Thank you there, King Roy. Thank you there, Walter. Here we go. Let's add some hydrochloric acid. Here we go, baby. And it goes 1, 2, 3, 4, 5, 6. Now, this is kind of cool. You can totally see that I have added hydrochloric acid, man. Come on now. Of course you know that, right? I added the acid. It's going down to pH 3. And we also know the acid is more dense than the alcohol, but less dense than the salt water. Come on, man. That's just cool. That is just cool. Thank you there, Paul. Thank you there, Saint. Hey, thank you, David. Thanks for the subscription. Now, when I shake this up, I don't know what pH it's going to end up at. It depends on whether there's more acid or base. If there's a perfectly equal amount of acid and base, we'll be at pH 7. Okay? If there's a little more acid, it'll be one of these colors, and a little more base will be one of these colors. The solvent in the upper layer, George, is George in the upper layer is isopropyl alcohol. Okay, and George, if you want to see how to do this in particular, you can look up the Journal of Chemical Education, and there's an article called "Rainbow in a Bottle," and you can check this out. Skylar, do I like acetaminophen? I sure do when I got a fever. Heck yeah, I do. Here we go. I just did a YouTube short on acetaminophen. You should check it out. Acetaminophen reacts with iron ions to make a blue-colored solution. Let's shake this up. Let's see what happens. It looks like everything's going to go red, but wait a minute. Wait a minute. It looks like the base might be taking over. What's going on? Maybe I perfectly balanced it and we're going to end up at neutral. I don't know. Let's just see. That's really interesting how there's like a shifting going on there. Thank you there, Anonymous. PG Dub, I don't know how I got all those colors, to be honest with you. I've never seen it oscillate like that, so I don't know if you all noticed, but when we first shook this up, I saw it go like red, but then it just kind of shifted back this way, which is really interesting. I'm wondering if some of you know what? I don't even know. I'm not even going to take a guess, because I don't know what the heck's going on. Oh, cool, Skylar. Classic test for checking if you converted all your salicylic acid to aspirin. Thank you there, Twinkle. Yeah, I thought aspirin doesn't contain a phenol. Yep, indeed. Thank you there, Eric Lee. Why is it separating, Jessica? The reason why it's separating into a colorless fluid like that is because this is salt water. Up here is alcohol, and salt water and alcohol don't mix. Now, the reason why it goes like this, why the colors go up here, is because the dyes dissolve better in the alcohol layer than they do the saltwater layer. Thank you there, folks. Let's give that a shake. It seems like there's something really weird going on there, some kind of weird non-mixing effect. I don't know. But hey, I just got to tell y'all, thanks for hanging out with me today. And just want to let you know, my grandpa's name was Walter. I don't know if that's a coincidence or not. You have to let me know. Here we go. Hey, thank you there. Thank you there, G. I'm going to try to say your name, and forgive me, I'm going to murder it, but you feel free to correct me. Geschichterner-Zoller. I apologize. I know I murdered it. And I should know better. I am German. My ethnicity is German, but I sure don't speak it. You can tell that. Okay, folks, I just want to let you know I'm getting near the end of I'm using Universal. I'm getting near the end of the live, and when I do that, I flip the camera around and I talk to people for a while. So if you don't want to, if you don't want to talk to me, just so you know, we're getting near the end, and that's what I do, okay? Can I emulsify this solution to a point that it stabilizes? D, I've not tried that, but I imagine if I put some detergent in here, it might work. Oh, storyteller. Thank you there. Thank you there, G. I'm just going to call you G. I'm so sorry. I am so uncultured. It's embarrassing. Hey, we got someone here from Guyana. King Roy, I usually go live on the weekends. Hey, what's going on, Advanced Production? Good to hear from you. All right, Eric. Thanks for hanging out. Okay, let's flip this camera around. Let's talk to folks. And, see what's going on here. I hope you like my t-shirt. Cool anecdote, bro. Now go collect some data. If you know, you know. If you like that kind of stuff, you can check out my my Dashery store. Hey, Willow, come on, man. Thank you. Thank you so much. Willow says, love your stuff, dude. Willow is on. Not necessary, but my hat's off to you, bud. I really appreciate it. Thank you, Willow. Thank you there, PG Dub. I'm not from Texas, Rishi. I'm not from Texas. Hello there, Raycon. Hello there, Rishi. Nice to hang out with folks. Give that a like. Get that up to 10 likes. My least favorite solvent, asks Skylar. I'm not a... Hey, thank you there, Twinkle. Thank you there, Twinkle. I'm not a synthetic chemist there, Skylar, so, I don't mess with solvents a whole lot. Thank you there, Tray Mover. Appreciate it. So long there, King Roy. You know what, Skylar? Yes, I agree with that big time. So long, King Roy. Oh, my goodness. NOK. Thank you so much. Thank you. You do not need to do that, but I really appreciate it. Come on now. Love it. Thank you there, Anon. Thank you so much, Anonymous. What's your favorite element? We got, hello there, Lacey. We got people dropping their favorite elements in the chat. Mine's hydrogen. We got Sabir saying wolfram or tungsten. Yes, missus, I am a teacher. Yep. Rishi, it is what it is, I teach general chemistry. What can I do? What can I do? I've been doing it for like 30 years. I remember some organic, but if I had to teach like organic 1 or organic 2, yeah, I'd want to retake the course first. Let's just put it that way. Manny. My opinion on gallium. Willow, I have recently done some new experiments with Gallinstan. Man, I'd love to tell you all what it is, but I've got some editing left to do. I discovered something new with Gallinstan. So Gallinstan, if you don't know, it's an alloy. It's a liquid metal alloy. It looks a lot like mercury. And it's a mixture of 3 elements, gallium, indium, and tin. And when you mix those three elements together in the right proportions, you get this nice silvery liquid. It looks just like mercury. The nice thing about gallon stand is it doesn't have the toxicity associated with it that mercury does. So you can hold it in your hand. I've seen people eat it. I wouldn't eat it. Or they like stick it on their eyes and stuff. I don't do that kind of stuff. But still, it's like, you know, it looks like mercury. It behaves a lot like mercury. It's about half as dense. But anyway, I figured out some cool stuff to do with it. I can't wait to share it with you. Uh-oh, Jason. Q, I usually go live at this time. So somewhere but in this time frame, this is a little later in the day, this day of the week. For me, it's Sunday. This is usually the time that I do it. Sometime between 2 hours before where we're at right now and this time right here. All right, folks, I had a blast with you today. Time to get the gloves off. Time to go hang out with my wife. It's about time for her to come home. I haven't seen her all day, and I'm looking forward to spending some time with her. So thanks for hanging out and checking out some of the beauty of science with me. We had a great time in the lab today. Let me just show you some of the stuff we did. Come on, man. Just some good stuff, and we are going to see you next time. So thanks for hanging out. Appreciate all the love. Consider following Tommy Technetium. Give it a like, give it a follow, give it a share with people who love science and love to see the beauty and the fun of science. And help me reach that goal of maybe one day hitting 1 million subscribers. We're working hard. We hope we're going to get there. Well, it's actually just me. I'm the one that does everything, all the writing and all. Anyway, all right, folks, so long. Good hanging out with you. See you next week.